Mathematics, the universal language, is everywhere around us. It's in the change you receive at the grocery store, the rhythm of your morning jog, the ticking of the clock on the wall. It's not just for scholars in ivory towers or number crunchers in corporate offices. It's a part of our everyday lives, shaping our understanding of the world. But here's the catch. Despite being so deeply woven into our existence, there are certain math questions that remain baffling to most adults. Consider Fermi's paradox, a question that combines mathematics with the vastness of the universe. It ponders on the contradiction between the high chances of extraterrestrial life and our lack of contact with them. With an estimated 100 billion galaxies each with billions of stars, it seems almost certain that intelligent life should exist elsewhere. Yet where is everybody? Various theories have been proposed, from the possibility of self-destruction to civilizations avoiding contact. So while we may never have a definitive answer, Fermi's paradox continues to provoke thought and speculation. Next, let's delve into the world of probability with the intriguing Monty Hall problem. Picture this. You're on a game show, presented with 3 doors. Behind one is a car, and behind the other 2, goats. You make your choice, let's say door number 1. But instead of revealing what's behind your chosen door, the host, who knows what's behind each door, opens another door, say door number 3, revealing a goat. Now, he gives you a choice. Stick with your initial choice, or switch to the remaining unopened door. Here's where it gets interesting. Your intuition might tell you that it doesn't matter if you switch or not, as there are 2 doors left. However, mathematically, your chances of winning actually increase to 2/3 if you switch. This is because your initial choice had a 1/3 chance of being correct, leaving a 2/3 chance that the car was behind one of the other doors. The Monty Hall problem, a classic example of how our intuition can sometimes clash with mathematical logic. Now let's explore some unsolved problems that have puzzled mathematicians for centuries. First up, the twin prime conjecture. This mathematical brain teaser suggests that there are infinitely many twin prime pairs, consecutive primes differing by just 2. While it's easy to comprehend, proving it has been a monumental task, and the question remains open to this day. Next, we have the Goldbach conjecture. This proposition has been around since the 18th century and posits that every even integer greater than 2 can be expressed as the sum of 2 prime numbers. Despite its simplicity, it's another problem that has eluded mathematicians for centuries. Moving on, we encounter the Riemann hypothesis. This famous unsolved problem is tied to the distribution of prime numbers. The hypothesis has significant implications for number theory, and despite many efforts, remains unproven. Then there's the P versus NP problem. This central question in computer science is about the efficiency of solving problems. The implications of a resolution are vast, affecting everything from cryptography to artificial intelligence. But like our previous conundrums, a solution remains elusive. Next, consider the Collatz conjecture. This problem, involving a sequence of integers, is deceptively simple. Yet it's a mystery whether the conjecture holds for all numbers, and attempts to prove or disprove it have so far been unsuccessful. Finally, we have the 4-color theorem. This theorem, dealing with coloring maps using only 4 colors without adjacent regions sharing the same color, is unique. It was proven in the late 20th century, but the proof relies on extensive computer calculations and is not universally accepted. These unsolved problems remind us of the limitless potential for discovery in mathematics. So, what do all these curious math questions tell us? From Fermi's paradox to the 4-color theorem, these mathematical conundrums challenge our understanding, push our boundaries, and ignite our curiosity. They remind us that despite the leaps and bounds in knowledge, there are still mysteries out there waiting to be solved. These questions, whether it's the counterintuitive nature of the Monty Hall problem, the seemingly simple yet unsolved Collatz conjecture, or the profound implications of the P versus NP problem, they all speak to the beauty of mathematics. They highlight the importance of critical thinking, of questioning, of exploring. And isn't that what mathematics is all about? It's not just about numbers or equations. It's about patterns, about logic, about understanding the world around us. So let's continue to challenge ourselves, to question, to explore, because every question in mathematics is an invitation to explore, to challenge ourselves, and to appreciate the beauty of this universal language.